After the massive asteroid impact 66 million years ago, non-avian dinosaurs were gone, photosynthesis was shut down, and global ecosystems were devastated. But after the raging fires, tsunamis, and freezing darkness, life did recover. How long this recovery took? Well, although life often takes millions of years to recover after some of the biggest mass extinction events in Earth's history, what if I told you life began recovering only about 30,000 years after the KPG impact, which is insanely fast given the circumstances? Well, it turns out I'm not actually telling you that, because a new study published in the journal Geology just reported a new estimate suggesting that life came back within less than 2,000 years, not 30,000 years after impact. And this wasn't some safe haven environment far away from the impact site. This was within the crater, which is crazy for more reasons than you think, and we'll get into it. Now, I know 2,000 years might sound like a pretty long time if we're talking human timescales, but for geologic time, especially after events like this, I mean, the climate remains unstable for millions of years after this and all other major extinction events in Earth's history. But for this specific event, it isn't just the unstable climate that makes this recovery seem so fast. It's also the conditions within the impact crater. Recall from the recent videos I made following the GSA field trip to the KPG boundary in Texas that the impact crater itself remained hot, like molten rock levels of hot, for tens of thousands of years, potentially even up to about 1 million years after impact. This is what makes life coming back inside the crater within 2,000 years a wild thing to think about. So let's break this down. What exactly do we mean by life coming back? Like, what do we count as the recovery of life? Well, there are a few different markers of biological recovery after an event like this. First, how soon do new species evolve? Second, when did marine productivity rebound? And third, how fast did ecosystems begin to reorganize? Past estimates had suggested that the first recovery phase, new species evolving, had occurred within around 30,000 years of impact. But these estimates were made assuming constant sedimentation rates. And according to this new study, sedimentation rates were not at all constant within the crater. The authors measured helium isotopes across 6 KPG boundary sites to calculate instantaneous sedimentation rates instead of averaged ones, and they found that instead of 30,000 years, the first new species appeared within less than 2,000 years of impact. And not only is this way faster than the 30,000 year estimate, it's also 2 orders of magnitude faster than most speciation events, which typically take around 2 million years. Even so-called rapid speciation events in the fossil record take hundreds of thousands of years. So this might have been one of the fastest bursts of evolutionary innovation that we've ever documented in Earth's deep time. So with all that said, you might be wondering, what kind of life was it that recovered this quickly inside a crater that was so hot that rocks were still molten? Yep, you guessed it. It was tiny life, specifically foraminifera, which are single-celled organisms with calcium carbonate shells that fortunately help them get preserved quite nicely in the rock record. Up to 10 to 20 new foraminifera taxa appeared within the crater within thousands of years after impact. And some research even shows that organisms colonized the crater before the iridium dust that marks the KPG boundary even finished settling. And the authors of this study think that the hydrothermal conditions within the crater actually helped rather than hindered these organisms. Hydrothermal fluids circulated nutrient-rich seawater, creating hydrothermal vent ecosystems potentially similar to those we see on Earth today. So instead of being this huge zone of death and destruction, the crater might have actually been kind of an oasis for life. And although these organisms are small, they are foundational within the food chain. They set the stage for later recovery of larger organisms. That said, the full restoration of ecosystem complexity took around 10 million years, give or take, so it was a bit slower. Even so, this study changes a lot about how we view extinction recovery. It shows that life can rebound astonishingly fast under the right conditions, that ecosystem engineers at the base of the food web matter, and that seemingly extreme environments like hydrothermal systems can sometimes act as catalysts for recovery. So I hope you guys enjoyed learning about this incredible comeback story. The paper is linked down in the description box below, as are other resources and references. And fun fact, this new paper paper is actually co-authored by one of the field trip leaders of the field trip that I went on to the KPG boundary in Texas. So shout out to Chris Lowery. And great news, if you're sad about missing that field trip, there will be another GSA Texas field trip coming up this April. So I'll be sharing more about that on my channel, as well as GSA's Geosociety channel and all of other GSA, social media platforms. So be sure to follow those. And with that, I'll see you guys in the next one, and hopefully in Texas in April. Bye.